Yeah, hi everyone. So today I'll be talking about generative AI and large language models. So we have seen a lot of large language model applications over the past 1 year, and that all started after ChatGPT. So I'll talk about what large language models are, what can we do with them, what are their limitations, and also, another very important question that I would like to answer is that were we in an AI stone age before large language models? The reason being, um, many people jumped into the field of AI after ChatGPT. They may not be aware of what was going on before LLMs came into the picture. For the applications of LLM, we already know they are everywhere. Simply put, they're everywhere, from question answers to image generation to different flavors of LLMs, I would say, are there in many applications. We'll cover some of them in this presentation. Why do I feel the need to create the series of talk? The first one is many talks that I find on the internet, they are by the users of the technology, not essentially by experts in AI. They explain the use cases very well, but they also create AI hype. Uh, they probably expect too much from the large language models, and they present them uh, as probably something very close to AGI, which is artificial general intelligence. Number two, I see a lot of experts who explain these technologies. They are kind of um they want to stay within their silos. Okay, they sometimes promote their own technologies. They sometimes go too much into the depth of a particular technology that is not required. Okay, and the number third and the main reason is that uh, the talks are there, but the materials used in the talks are not open source. They are not available. For example, the slides, the code that are used in the slides, they are not open source. So my plan is to share all the materials in this series of talks in this GitHub repository. So you'll be able to go after watching this video and you can download the slides. um, I use material from many other papers and articles and sources. I always cite them. I follow the licenses. I hope that you will also read the license at ML course and use it accordingly. Let me start with what is AI. AI is often presented as a magic. It is not magic, not at all. Okay. AI is very simple. We want to go from an input to an output. The input is X, the output is Y. Okay. Input can be anything. It can be, for example, weather data, it can be image data. The output can be, for example, the weather forecast. It can be the label of that image. For example, if we give an image of a cat, we expect the output Y to be a cat. Okay. Uh, and then generative AI came along. It did not start from ChatGPT, but suddenly it became much more commonly known after ChatGPT. Um, what generative AI, the difference between generative AI and predictive AI or conventional AI is explained in the right hand side figure. Uh, Conventional machine learning algorithms tend to rely more on data that is labeled. Okay, for example, image and label pair is required to train a model for image classification. Okay. So predictive machine learning models output numbers, they output classes, they output probabilities, yes, no, for example, if the data contains an anomaly or not. Okay. On the other hand, generative AI models are mainly mainly trained on unstructured content. They do use some supervised training in some cases. I'll discuss that later. But the majority of training happens on unstructured data where the model just learned to predict the next word or next token. um, Generative AI models basically generate new data. Okay, they generate language, they can generate image. Okay, they can generate different sources of data. They can generate an image given the input in natural language for multimodal uh, generative AI models. These terms are often interchangeably used, they are confused, um, but they all mean a little bit different things. So, starting from large language models. So, large language models are basically the models like ChatGPT, Bard that we use very commonly. For example, explain in natural language and ask the model to generate a Python code for us. These are large language models. They are based on foundation models. So, foundation models are the models that were trained on huge amount of unlabeled data. Okay, and most of the foundation models, and because of that the large language model, they're based on transformer architecture that was presented in 2017 paper attention is all you need. Okay. And um, all this is generative AI. Is generative AI only large language models? No, definitely no. There are other architectures. For example, like going back to where it started in 2014, um, GANs, generative adversarial networks. Okay, that are also generative AI, and there are much more. What is the major difference between traditional AI models and foundation models? I think this slide explained it fairly well. In the traditional AI model, we have to have a separate model for each task that we need to perform. If we want to do question answering, we train a model, independent model, to do that task. If you want image classification, we train another model, and so on and so forth. We have the number of model is equal to the number of tasks that we want to perform. In case of foundation models, what we do is we can potentially have many different domains of data: image, audio, speech, text, of course. And then we can train using the huge amounts of unlabeled data. We can generate a very big model called foundation model. Okay, this foundation model can be used for many different applications, even the applications that it was never trained for. There are two main ways of using foundation models. One is prompting. Okay. In prompting, what we do is we show few examples to the model, and because it have seen a huge amount of unlabeled data, just by few examples it can understand what we want it to do. For example, we can show it a sentence and we can say it's a positive or negative sentiment sentence, and then we can show few examples of positive sentiment, few example of negative, and then we give a sentence where the sentiment is unknown and the model understands what it needs to do, what we want from it. So that's prompting. It's also called ICL, or in context learning. The other way of using foundation model is fine tune the model. If you have some proprietary data within your enterprise that you want to use, you can fine tune the model. Okay, with a little bit of proprietary data, you can fine tune the model and you can make it perform even better for your specific use cases. Okay, this seems like massive training massive foundation model seems like very costly, which it is. But in down the line, it actually reduces your overall cost because now you can do a lot of different tasks with a single model. Okay, so there is a lower upfront cost whenever you have to do uh, some new task. You need very little labeled data because most of the foundation model, like mainly it was trained on unlabeled data. And still, even though it can perform many tasks, the accuracy is better or equal to what you can achieve by training a single model for single task. So how did we reach here? How did we reach the era of foundation models or era of large language models? Uh, the story of AI begins like in the middle of the last century. Before 1980s, the main AI technology was expert systems. Okay, where the experts used to define a lot of if-then rules, and there was inference engine. The inference engine, uh, based on the observation, it used to determine, or it determines which rules it needs to fire. Okay. Uh, the inference engine is also responsible to decide to take a decision whenever conflicting rules are firing, and so on and so forth. Is it still dead? No. We still have systems, even in autonomous driving, that still are based on expert systems or expert rule based systems. Then came the era of big data. Okay, this is where mainly we were interested in learning boundaries between the data. Okay, so if we have two classes of data, we can learn the boundary. Then whenever we get a new data, we can determine if it's in class A or class B. Feature engineering, because we had to reduce the dimensions of the feature. We were not able to give, for example, the full high resolution images. The processing power was not there, the algorithms were not that mature. So feature engineering, dimensionality reduction, all that was very common um, in this era. From 2012, around 2012 onwards, came the era of deep learning. And in deep learning, um, basically what happened is that massive amount of labeled data and massive amount of compute because of GPUs became readily available, and that unleashed the era of deep learning. From algorithms point of view, it's not very different from what we had before, but of course there are some significant improvements to those algorithms that enabled this era. We saw many different architectures, from multi-layer perceptrons to convolutional neural networks to recurrent neural network, LSTMs, um, a lot of different architectures. But one thing remained common: we still need to have a separate model for each task. Okay, so here you can see each task needs a separate model with a different kind of architecture. Okay, potentially. From 2017, that's when the Transformers paper "Attention is All You Need" was published. Onward, another thing that came into the picture was self-supervision at scale. We now became able to train our models on huge amount of unlabeled data. Okay, that is what enabled foundation model era or large language models era. um, Here we can have a single model, and later we can just prompt. By prompt, I just mean ask the model to perform different tasks. We can say, can you answer to this question? And we can ask the question. And we can say, can you summarize this article? And then we can give the article and it will summarize. So basically, we can perform different tasks using a single model. what's the major difference between generative AI and traditional AI? Okay. So as I said, so in generative AI, one of the major differences is that most of the training, let's be very clear, not all the training. Okay, there in ChatGPT like model there is a part that is labeled training. Okay, but most of the training is unlabeled in case of generative AI. Traditional AI used to depend more on the labeled training. Okay, also called as supervised training. um, Generative AI, we now have internet scale data sets. It's really huge data sets became available. And they are not task specific. Generative AI is general. We can um, basically train one model and perform different tasks using that. Traditional AI used to be task specific. Some features remain similar. Okay, we'll come to that. For example, when we come to the problem of bias, drift, ethics, governance, lifecycle management, all that remain the same. Okay, but these are some basic differences between these two AI paradigms. Okay, were we living in an AI stone age before large language models? The answer is no. We had many different architectures, many different applications. Actually, the large language models are largely based on algorithms and architectures we had before um, ChatGPT era. Okay. We had very good AI technologies, architectures, and algorithms before ChatGPT. Um, will traditional AI remain relevant, or will everything become generative AI? So the answer is very simple. Traditional AI will remain relevant even when generative AI become much more accessible due to smaller models and more compute power. But just like expert systems mainly dominated AI before 1980s, but they are still relevant. Similarly, whenever you want to perform simple, very efficient AI task like AI decision making or something, the traditional AI will remain extremely relevant. Actually, for training large language models, there are paths that use traditional models uh, to perform to train these large language models. I'll discuss a little bit in the coming slide. And then generative AI predates ChatGPT. It did not start with ChatGPT. It did not start with attention is all you need paper. It was there before that. What happened after ChatGPT? First and foremost, AI was for the first time brought to masses. Okay, everyone was directly able to see and interact with an AI system. It was first it was the first time when it was like some model that is publicly available is trained on massive amount of data. um, it's almost covering the data that is available on the internet, most of the data that is available on the internet. Okay. And the ability, it's general enough that it can perform tasks that it never saw during the training. That's what also people found very interesting. This is arguably, this is where the generative AI started. Even before that, before this, there was VAEs or AEs, autoencoders, and they were also generative in a way. Um, I worked significantly on VAEs and AEs before this. Then generative adversarial networks, GANs, came in around year 2014 after this paper was published. The idea here is very simple. We have two networks that are kind of competing with each other, and we want to train them both. We have real data samples, and we have a generator. Okay, generator generate data that looks like a real data, okay, real distribution. The job of discriminator is to tell which of the data is real, which of the data is generated. Over time, the generator keeps learning how to make better and better images, or better and better data, and discriminator learns how to be very good at telling the difference between um, the real data and the fake data. Okay, and once we keep on training these two in a adversarial manner, we reach a stage where the generator is able to generate very good images. Okay. On the right hand side, there is an example taken from one of the research. On the top, you can see source images. On the left hand side, you see style images, and then the GAN is asked to generate the source image in the style of the style images. Okay, so how are these models trained? In step number one, they are actually trained on huge amount of the unlabeled data that is available. It can be billion to trillion tokens, several trillion tokens. Okay, we'll not discuss what token is, but let's suppose it's a word. Okay. Then comes supervised fine tuning. This is the step number two. In step number two, we give some amount of labeled data or specific instructions to the model. It's much smaller than what was used in pre-training. Okay, this is where the model learns to follow the instruction that we give. Here the example can be like, what is the answer to this question, and then there is a question, and then the answer, and the model learns to answer the questions using this way. The third one, very important, is alignment. Okay, alignment is where we ask the model to generate the output, and we ask human annotators to tell the model how good or bad the output is, and over time the model learns to how better align itself with human evaluations. On the right hand side, you can see the blue line shows how GPT-3 performs just by prompting, just by asking it to do something. Green line shows what happens after supervised tuning, fine tuning, and the red line here shows what happens after supervised fine tuning and alignment or reinforcement learning with human feedback. A little bit about how large language models work. I'll cover it in the subsequent slides. So they are simply next word predictors, nothing more, nothing less. Okay. For example, given this sentence, a quick brown fox jumped over a lazy, and the model will predict what should come next based on everything it has seen. Most of the models will say dog because they have seen the sentence many times in the training data. A little bit more complex than this. They are actually not just giving out the next word. They're giving a probability distribution or likelihood of the next word that should appear. So they should say, like, okay, cat can appear, dog can appear, man can appear, boy can appear, grass can appear, but the probability of dog is highest. Okay, so it depends on everything it has seen before to determine what should come next. The applications of LLMs, they are numerous, but for example, like summarization, captioning, question answering, even solving exam papers, source code generation, which is super interesting, natural language understanding for sure, retrieval and generation. We'll cover that in one of the upcoming talks. We should also understand the limitations of LLMs. Just understanding the power is not enough. There are many limitations of LLMs. We must be very careful when we use them. They hallucinate a lot. Okay, that means that they can generate some facts that does not exist, that are not real. They have bias and ethics problem. For example, in the bottom right corner, in the early days of ChatGPT, someone asked it how to check if someone is a good scientist or not in Python on based on JSON, and it said if the race is white and gender is male, return true. So now it does not return this, but this kind of biases can creep into the models. Okay. Uh, there are a lot of other concerns also that interacting with these models, you can basically make them uh, give very instructions to something very potentially dangerous. Okay, we saw many news articles and other papers also talking about. On the bottom, I asked it a question. I have two bananas. One fell down. How many are left in the room? And it gave me the wrong answer. Okay, it's so simple, but we should understand that at one from one dimension they are like too cool. On the other side, they can commit very basic mistakes. Okay. uh, so they are not explainable. They do tell how they reached a conclusion. They can tell, but um, they are not explainable in traditional sense. Okay. Going forward, like what does the future hold for them? um, there are many issues. um, Maybe I believe we will reach the saturation point of large language models very quickly, but at the same time I do believe strongly that there are many other technologies that have not yet been tried with large language models, and once we combine those technologies, there can be another revolution. That is the next phase of uh, large language models. For example, the reversal curse on the right hand side. When you ask a model who is Tom Cruise's mother, it can name her, but when you say who is Mary Lee's son, it cannot, because it was not trained in the reverse direction so much. So this kind of reasoning for a traditional reasoning system is very easy to solve, but for a large language model, it's a problem. Uh, then we saw papers like Orca, where it also highlights the danger of smaller models, where smaller model learn to imitate the style of larger model, but does not possess the um, capabilities of these large foundation models. Okay, so let me wrap up my presentation. So let me talk a little bit about AGI hype, artificial general intelligence hype that we have, that uh, LLMs will take over the world, or um, God knows what will happen. But right now we have nothing to worry about. Let me briefly explain why. Um, we had an era of, like, until few years back, we had an era of narrow AI where we had a single model for a single task. They were dependent on large amount of labeled data. And right now we are in the era of broad AI, where we can have a single model that can work on multiple domains, that can work on multiple tasks, and they can perform a variety of tasks that were not essentially possible with the narrow AI. But that being said, these broad AI models are also as naive. They don't have any memory, they don't have any intrinsic motivation to do anything. Okay. um, we are moving towards general AI. Okay. That will, of course, we'll see another revolution in AI. um, that will be very similar to um, what the kind of AI or intelligence that we see in humans. Okay. But how and what will be the shape of it, it's not clear. When exactly will we reach that? Still, it's not clear. But one thing is for sure, that these large language models, they will never rule us in this form. Okay, so we need something else that is missing right now with LLMs. Okay, so there is no need to spread that kind of hype in this area. Thank you. I'll post more talks in future. You can follow me on LinkedIn. I have given links to X, Twitter, Threads, and as I said, you should be able to download this talk in the ML course GitHub repository. Of course, you can see other talks also on my YouTube channel. Thank you.